Okay, so we're going to work through some derivatives using the chain rule. The first one I have here is y equals the natural log of 2x plus 2. So keep in mind that we do have a derivative formula for natural log. Derivative of natural log of x is 1 over x. But I don't have x in here. I have 2x plus 2. So we use the chain rule version of this. So the natural log of u equals 1 over u times u prime. So the 2x plus 2 is my u here. So the derivative of this thing will be y prime equals 1 over that u, which will be 2x plus 2, and it'll be times the derivative of 2x plus 2, which would just be 2. So derivative of u, which is u prime, would be 2. So just kind of highlighting all the things here that might help you understand where everything's coming from. Pretty simple problem. All right, next one. All right, so the next problem is y equals, and it's the fraction 1 plus natural log of x over the denominator 1 minus natural log of x. And while this doesn't use a chain rule, I believe, it does use the quotient rule. So the quotient rule is the derivative of u over v equals v times u prime minus u times v prime, and then that's all over v squared. So in our case right here, our u will be 1 plus the natural log of x, and our v will be 1 minus the natural log of x. If that's the case, u prime will be derivative of 1 is 0, and derivative of natural log of x is 1 over x. For v, derivative of 1 is 0, and negative natural log of x will give me negative 1 over x. So I just need to put all this back together. So y prime will be the fraction on top. Oops, excuse me. It'll be v, 1 minus natural log of x, times u prime, which is 1 over x, minus u, which is 1 plus natural log of x, times v, which is the negative 1 over x, all over v squared. And that would be 1 minus natural log of x squared. So I'm going to use some colors to kind of bring some things out. U v in several places, and then u prime, and v prime. We need another color. I guess orange will do. So with all that, we could clean this up a little bit. I don't know how much we want to do. You don't have to clean up, but maybe it'll be 1 minus the natural log of x over x plus 1 plus the natural log of x over x. And it looks like we got a common denominator up there, so we could keep going. But it'll be 1 big fraction over 1 minus natural log of x squared. And I see that if you were to do a few things, you could clean that up, and the shorthand of that would be, let's see, the natural logs would cancel out up top. So you'd have 2 over x, and then that would be, in the end, 2 over x times 1 minus natural log of x, and that would be squared if you clean that up. Okay, let's try another one. Okay, so we've got the function y equals y equals log base 4 of x plus log base 4 of x squared. So we're definitely going to need our log derivative. So derivative of a logarithm base a of x is 1 over x, times the natural log of a. 1 over x times the natural log of a. And that'll work really good for the first one. But the second one's a little bit more complicated, so we're really looking at log base a of u. So that'd be 1 over u times the natural log of a, and that'd be times u prime. So two different things here. So let's work on it. The first one here, log base 4 of x. So that'll be 1 over x times natural log of 4. Pretty simple. If we're trying to figure out where things come from, here's the x. And another color, this yellow, here's the 4 in that formula. Come on, buddy. Why aren't you highlighting? There we go. I don't know what happens. Sometimes it freezes up. But for the second part, log base 4 of x squared, we'll have to use that chain rule part. So plus, it'll be, okay, so let's see here. Let's use a color we haven't used. My board's freezing up. Oh, there it goes. So let's use this blue here. The x squared, that's my u. Okay, so in that case, if that's my u, the u prime, which would be the derivative of x squared, would be 2x. So let's see if we can fill this in. So we'll have plus 1 over x squared times the natural log of 4 times 2x. So let's do some good color coding here. Oh, excuse me, not that. Hold on. Yeah, something's freezing up here as I go, so we'll try and get there though. So in this case, 4 is the A. And the u prime here, which I need a color I haven't used, let's use this reddish one, is the 2x. Okay. And we're done there. If we want to clean up a little bit, we could. It looks like we could take the second one here and clean up a little bit. But the first one, 1 over x times natural log of 4 plus, and if I put this 2x over this x squared, we can throw out a x. So x over x squared, one will cancel out. So it looks like we got common denominators there. So if you really want to clean this up, it looks like it could be 3 over x times natural log of 4. So if you do carry it out, you get something much nicer, but you don't have to carry it out. All right, we got one more. All right, last example here, y equals 7 times the square root of 9x cubed plus 5x. And then you're going to subtract outside of that the fraction 1 over 4 minus 7. So I'm going to rewrite this a little bit first. Y equals 7 times 9x cubed plus 5x to the 1/2 minus 1 over 4x minus 7. So we'll talk about these in individual parts, but let's do the first part first, 7 times the square root here. This is definitely a chain rule. So the u part of this will be what's in parentheses here, the 9x cubed plus 5x. That'll be the u, and if that's the u prime that we'll tack on will be 27x squared plus 5. So when I go to write out a derivative, I'll have y prime equals 7 times, now I'm going to apply the power rule on the u to the 1/2 times 1/2. That'll go down to negative 1/2. And u will go back inside the parentheses, and u prime will go on the outside. So we will have, come on colors, inside here 9x cubed plus 5x, and on the outside 27x squared plus 5. So just matching things up here. I apologize. I think while I'm making this, there's no internet, and the thing that I'm writing on is a live stream, so it keeps freezing up my pens here. Okay, but let's go with the fraction here. We got minus 1 over 4x minus 7. Now, you could bring that 4x minus 7 up to the to the top and make it to the -1 and use a chain rule, but I'm going to use a quotient rule instead. Okay, quotient rule. So the quotient rule on this, the u will be 1, the v will be 4x minus 7, u prime will be 0, and v prime will be 4. So when we go to put this derivative together, we've got the minus out front, so we're going to do the fraction of v, 4x minus 7 times u prime, minus u times v prime, all over v squared. So that's the 4x minus 7 squared on the bottom. So let me color code some of that for you, just in case you're worried. V all over the place came from the denominator. U came from the numerator. U prime, which is just going to knock it out, and then v prime. Alright, so all that's color coordinated. I do think it's worth cleaning up a little bit, mainly because with the first one I can rearrange things a little bit. So I'll have 7/2 9x cubed plus 5x to the -1/2, and then times 27x squared plus 5. And you may want to take it further. We can all kind of agree or disagree how far to take it. With the quotient rule at the end, the first part times 0 will go away. So I'll have a minus out front and a minus on top, so it'll give me plus 4 over 4x minus 7 squared. And like I said, you could do some different things with that and clean it up, but I don't see why it's all that necessary if you are happy with what you got. All right, thank you.